Greetings everyone! Today we're going to explore parallel and perpendicular lines. My apologies for my voice, I'm still fighting this cold. So make sure that you pause the video at any time and rewind if you need to rehear anything. Today we're going to decide whether lines are parallel, perpendicular, or neither. And we're going to write equations of lines that are parallel or perpendicular. Alrighty, in your notes we're going to have to go over some key vocabulary first. This term I know you all are very familiar with, and that is parallel lines. The definition is lines who never intersect. Again, as you're taking notes, make sure to pause to finish writing before we continue. A key feature about parallel lines is they have the same slope, which makes sense because they're both increasing or maybe they're both decreasing. They run alongside each other is another way to think of it. Therefore, they have to have the same slope. Let's talk about the symbol for parallel. To use a symbol for parallel, you can draw two skinny lines. They should be taller and longer than your letters. That way they're not confused as an 11. We also write them very close to each other. So in the future, in your notes, on work, if you want to abbreviate or shorthand the word parallel, you can use the symbol. There is one case of special parallel lines, and that is vertical lines are parallel if they have different x-intercepts. So let's quickly just think about vertical line slopes. Vertical line slopes are undefined. So therefore I can't use the same description of having the same slope. So in a special case like this, we generalize it and just say all vertical lines are parallel if they have different x-intercepts. All right, in your notes, I do want you to write the examples down. You don't need to write all of this. You can just write down the part that I'm going to underline in red. So in this example, if a line passes through 12, 5 and is parallel to the graph, so keyword parallel to the graph of 2/3 x minus 1. Write an equation of a line in any form. So again, you can choose slope-intercept or translated. So first, let's identify the key features. If the given graph has a slope of 2/3, then my line better have the same slope of 2/3. If I want my line to go through the point 12, 5, then I need to include that 12, 5 in my equation. Take a moment. Would it be easier to use slope-intercept form or translated form? Let's use translated form. So I would start off by writing y equals the slope of 2/3, parentheses, x minus 12, close parentheses, plus 5. So pretty simple. This is very much like our previous lesson of writing lines from information. It's just the information is talking about a parallel line. That makes this example a little quicker. A line passes through -3, -1, and is parallel to the graph of 2x plus 3. Write the equation in any form. So first, if I identify my key features, I have a slope of 2, because they're parallel, it would be the same, and a point of -3, -1. So to write my equation, let's do translated form. Y equals 2 parentheses x plus 3 with a minus 1. Some more vocabulary. Perpendicular lines. Perpendicular lines are lines whose intersect at a 90-degree angle. More importantly, in this lesson, they have slopes that are opposite reciprocals of each other. Two key features. The slopes are opposite reciprocals. Please underline, highlight, or make those two words stand out in your notes. Let's talk about the symbol for perpendicular. The symbol for perpendicular looks like an upside down T. The T itself better have a 90-degree angle. And so in the future, in your notes or on work, if you want to abbreviate the word perpendicular, you can use the symbol. Again, if you need to pause at any time or rewind, please do so that you're not rushing. Let's clearly identify those underlined or highlighted words, opposite reciprocals. The mathematical definition is two numbers whose product is -1. Two numbers whose product, what does product mean? That means to multiply. Okay, so if I multiply two numbers and I get -1, that means they're reciprocals. A shortcut way to think of this, a generic way, is to say that the slope is flipped and the sign is changed. Two things. Keyword and. The slope is flipped and the sign is changed. So, for example, don't mind my writing here as I'm using my laptop. If I have the number 2/3 and I multiply it by the reciprocal opposite would be a negative, reciprocal would be 3/2. To multiply fractions, we multiply straight across. So that would get me a -6 over a +6, which divided gets me to -1. So they are true opposite reciprocals. Special case though, when we have vertical lines, we can't talk about their slopes because their slope is undefined. So a vertical line is always perpendicular to a horizontal line. That makes sense, but we just have to consider that undefined slope. All right, let's take a look at some more examples. EX3. Are the graphs of these two equations parallel, perpendicular, or neither? So first let's write down just the two equations. Now if you'll notice on that red equation, I don't know what the slope is yet because I haven't isolated the y. So I need to divide everything by 4. That gets me to here. Now I know that the slope of the red line is -5/4. On the green line, I know that the slope is 4/5. So if I compare those two, are they parallel? Meaning, are the slopes the same? Nope. Are the slopes flipped and signs changed? They are. So in that case, these two lines are perpendicular. All right, let's take a look at another example. Again, you don't have to write it all down, just the red underlined pieces. In this example, a line passes through 12, 5 and is perpendicular to the graph of 2/3 x minus 1. We want to write a new equation using that information. So the first thing I need to notice is the given line has a slope of 2/3, but I want my line to be perpendicular. So what do I need to do to 2/3? I need to flip it and change the sign. So my new slope that I need to use, and I want you to write m equals when you're doing this process on your homework as well, is -3/2. My point is still 12, 5. So my new equation would be easiest to write in translated form. We end up with a -3/2 with an x minus 12 and a plus 5. Let's try one more. And I'd encourage you to try pausing this video and trying this one on your own to make sure you understand the concept. Then listen to it to see if you got it right. A line passes through -3, -1 and is perpendicular to the graph of 2x plus 3. Let's write a new line. If my given slope is 2, what's my perpendicular slope? It is -1/2. And it still has to go through the point -3, -1. So let's write our new equation of a line. I'm going to start off with y equals, followed by -1/2, followed by my x plus 3 and my minus 1. Alrighty, so there's some examples on parallel and perpendicular lines and writing the equations. Again, continue to choose what form you'd like to write it in, slope-intercept or translated form. And make sure to check Google Classroom to see what else we need to accomplish. Have a good one.